They're kind of the unsung heroes of architecture, aren't they? In pretty much every building you've ever been in, you probably never even notice them. But they are the unseen supports literally holding our world together. Today, we're talking all about lintels and beams. So, have you ever walked through a doorway and just stopped and wondered, what's actually stopping all that brick and material right above my head from just crashing down? I mean, it seems like it's defying gravity, but it's not magic. Nope, it's engineering. See, every building is in this constant, invisible battle with gravity. And whenever we create an opening, like a door or a window, we interrupt the wall's natural ability to support the weight above it. So, we need some special components to come in, bridge that gap, and carry the load safely. And that brings us to the two stars of today's explainer, lintels and beams. These are the structural components that solve this exact problem. Now, they might sound pretty similar, but they have really distinct and absolutely crucial roles. So let's break them down. Okay, first up, the lintel. Think of it like a strong shoulder that carries the weight of the wall directly over an opening. Without it, the wall above your front door, it would just crack and collapse. So the big takeaway is this. If you see a door or a window, you can bet there's a lintel hiding just above it, doing some serious heavy lifting. Now, let's talk about its bigger cousin, the beam. A beam is also a horizontal support, sure, but it works on a much, much larger scale. It's designed to carry massive loads. We're talking an entire floor or even a roof across a really wide space, and then transfer all that weight over to columns or walls. So what's the simple difference here? Well, this slide nails it. A lintel is for those smaller openings, right? Doors and windows. A beam is for spanning really large spaces. You could say lintels are for gaps, while beams are for entire rooms or whole structures. One's a specialist, the other is a heavy-duty generalist. Simple as that. Okay, so we know what they are, but how in the world are they actually made? It's not just about slapping down a slab of concrete. It's this precise, multi-step process that ensures everything is strong and safe. Let's walk through how it's built, step by step. Now, what's really cool here is how each step builds on the last one. You start with super precise measurements. Then you build a mold, the formwork. And here is the secret sauce. You place steel bars inside. Why? Well, concrete is incredibly strong when you squeeze it, that's called compression, but it's surprisingly weak if you try to pull it apart. And steel? It's the exact opposite. It's a champion against tension. You put them together, and you get this amazing super material. After that, you pour the concrete, level it all out, and then comes maybe the most crucial step of all. You just wait. You have to let it cure and gain its full strength before you carefully remove that mold. And listen, doing it right is everything. Building these supports isn't just about following steps. It's about meeting really high standards. The difference between a great job and a costly mistake can be just a few millimeters or a single poorly mixed batch of concrete. So what does a perfect job actually look like? This, right here, this is your quality checklist. A well-made lintel or beam is perfectly straight and level. There are absolutely no cracks, and it feels completely solid. And just like this slide shows, the size, the shape, and where that steel is placed inside, it all has to be exactly as designed to handle its specific load. And on the flip side, these are the big critical errors you have to avoid. Wrong measurements? Well, it either won't fit or, even worse, it won't support the load correctly. A poor concrete mix means it'll be brittle and weak. Not letting it cure long enough? Yeah, that's like taking a cake out of the oven way too early. It's just going to crumble under pressure. And weak formwork is a total disaster waiting to happen. The mold could literally break during the pour, ruining the whole thing. And let's be really clear about this. These are not minor errors. Any one of these mistakes can lead to this structural failure. And that means cracks, collapses, and extremely dangerous situations. This is exactly why the standards are so incredibly high. Okay, we've covered a lot. So to help you remember the absolute essentials, I've got a super simple trick for you. It's a great little way to lock in these key concepts for good. Just remember LBSC. L is for lintel, the one over a door. B is for beam, that big, beefy support. S is for the steel inside that gives it its real strength. And C is for the concrete that, holds it all together. So the next time you walk through a doorway, you'll know all about the invisible force keeping you safe. And it makes you wonder, what other unseen structures are holding our world together?